you kind of stand those up? Today we are starting the 4th unit of grade 9 academic math. Yeah, 4th of 7 or 8, depending on how I.
Maybe on the 8th and be done.
Eventually, yes. Ladies. So this unit continues to deal with lines. So it is carrying on. Phones away, please. Thank you very much. It carries on dealing with lines. Oh, by the way, I didn't mean just down, but still looking at them, by the way. If you're wondering, sorry, I mean, I know sometimes my language isn't clear, so, away could mean like, hey, continue playing with your phone, but do it down here. But that's not what I meant, just if you're wondering. This really melds last unit and the unit before that. So what we're going to do now is we're going to continue dealing with lines, but we're going to start dealing with them algebraically, right? So we're going to start thinking about lines more as equations and manipulating those equations. So it's going to take all the conceptual stuff from last unit about relationships in the real world that are modeled well by straight lines. But we're going to start using our algebraic skills, our equation solving skills that we learned in units 2 and 3, or in unit 2 rather, to combine with what we learned in unit 3. So I hope that makes some kind of sense. Today's lesson is kind of an important one. This is kind of a crucial one. This is the most common type of equation we're going to do in this stuff. So this is kind of the linchpin of most of the unit. It's an important one. Would you kind of tear those up for me? I did want to mention, for those of you who did not write your test yesterday because you were absent, because you're at student voice or whatever, I'm going to ask that you do so today. Catch me at lunch, catch me after school, catch me whatever. Catch me if you can. I'm going to run away. Because we have to have our midterm marks submitted tomorrow. I'd very much like everyone's test to be on it. Sorry? Yeah. Okay. We've been like end of unit stuff, so in little journals we've been focusing. But now we're back just in the sort of early learning stage. So so I'll have your test back to you tomorrow, one way or another. If for some reason you missed it and you don't make it up, then you'll only be eligible for the retest. All right, I want to get these tests marked and back. I hate hanging on to these things for days and days and days. I know when I used to write a test, I hated when it took days to get it back. I like to try to get things back the next day, but we had a big chunk of people absent yesterday, so I'll get them back to you tomorrow. Please, 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 if you haven't already, make arrangements with me to figure out when we're going to get that written for you if you were absent yesterday. Okay, I want to talk just quickly about the outline of this unit. This is probably the longest unit. No, that's not true. It's not as long as we made unit 2, but it's the longest of the remaining units. Longest of the remaining units, but we're going to take our time with it. One of the nice things is we've made pretty good time going through the course so far. You guys have done good. I'm about 1 day behind where I would have been ideally, and I'll tell you right now, being just 1 day behind when you're planning out a course, that's tremendous. Often I'm 7 days behind where I'd like to be. So this is great. We're in good shape, which means that we're going to have a good amount of time to spend on this unit and make sure we take it nice and slowly and that we get those skills in. And we should be in no danger of not finishing this course, which is nice. It's always awful when you've got like 2 weeks left and like 52 things to teach and you go, okay, what are these kids not going to know for the rest of their math careers? How am I going to choose to screw them over? So in this case, we don't have to do that, which is nice. Yeah. Did you not? Okay, I'm sure I have it back there. Here's the deal too. I've got a bunch of stuff to return that I'm hanging on to just because when I write your report card comments, it's kind of nice to have some recent assignments to look at, to comment on. So if you feel like you haven't got some stuff back in a while, that's part of why. When I write your report card comments, I like to have sort of your stuff. So on Thursday, you should expect to get a big old pile of stuff back. Yes? They mailed them out, so I can't. I don't know the exact. Well, I know the date that they mail them. I don't know what date that will mean you'll get them at home. But we are submitting them tomorrow. Thursday they get proofed. Friday they get mailed out. So whenever that leads to arrival at home, I have no idea. But yeah, hopefully Monday. But that's the thing. By the way, I won't have your numbers finalized until tomorrow. But after tomorrow, if you want to know the number, if you want a sneak preview of what your midterm is, I'm happy to show you. And I'll even show you your comment if you want. It'll say like, Shayla's a bad apple, worst kid in my class, can't stand her. Yeah, that's verbatim what I'm going to type, just so you know. But then we have to put like an encouraging comment at the end. So like I'm going to write like, I hope she gets better. And that's the plan. It's a joke, by the way, if anyone's listening. Had to happen eventually. So anyway, I just want to quickly walk you through. There'll be 7 lessons this unit, 4.1 through 4.7. What will the assessments be? Yep. 2 assignments, 2 quizzes, and then of course the unit test. I may also try to do a little projecty thing in there. I have a vision of something I've been trying to make on the computer. So far it's been met with failure twice. 2 late nights at a computer trying to make something only to discover that's failing miserably. But I'm going to give it a couple more tries. So we may end up putting a little project in here. We may not. I didn't put it on the tracking sheet because then I'd feel guilty every time I looked at it if we didn't get to that. But there could also be a little project. We'll see. Yeah.
Does it involve gizmos?
No.
Thank you.
No, I made a solemn swear. I made a solemn promise there would be no more gizmos. You'll see Desmos again. Suck it up. You're going to see lots of Desmos, but no more gizmos. Listen, can I tell you something? If you're going to carry on taking academic math, Desmos is going to be your best friend. You're going to go to bed at night thanking God that Desmos exists and wake up in the morning checking to make sure it still exists. All right, just trust me. I grew up in the era of math where all that stuff the computer now does for us instantly, we had to do by hand, and I can assure you, you don't want to complain about Desmos. Anyway. Okay. Today, oh no, that should say form. Oh no, the first sentence of the note, and it's a mistake. This is why we don't make our lessons late at night. Lines in the form.
Can there be quotation marks? Y is equal to M supposed to be?
No. No. We'll have a different discussion later about the incredible overuse of quotation marks in secondary school writing. I used to have a boss. This is neither here nor there. But my first boss owned the first restaurant I ever worked at. I worked there for 11 years. I did every single job in that building. I started as a dishwasher, and by the end I had dishwashed, bus tables, been a cook, been a host, been a bartender, been a server. Eventually I was the assistant general manager, then the general manager. I did every single job in the building. But my boss there wrote all the menus himself, and he would put everything in quotation marks, it would say a fan favorite, and that'd be just every single description of the menu had something in quotation marks. And so we used to, if we had to send him a memo or send him an email or something, we'd just put random words in quotation marks, and we always thought we were quite funny. Anyway, okay, so I want to do a little housekeeping. Last unit, we learned how to find the rate of change, and we learned how to find the initial value. Hold on. Hey, can I give you this, please? Okay, so we learned how to find the rate of change and the initial value. What 3 ways looking did we find these things? 1.
Find the difference between 2 points.
Sure, so we could actually look at the graph, pick 2 points, and find the difference between them. And we could also, of course, find the initial value on a graph, right? How else did we find the initial value and the rate of change? Looking at a graph, what else? Yep. No, you got this.
Looking at a graph.
So we can look at a graph?
What is that, a table?
Good. We can look at the table of values. So we know how to find the rate of change and the initial value just looking at a table. And finally, the last step that we learned last unit is even if I just gave you what? What's the least information, ladies? Pay attention to me. Least information I give you?
2 points.
2 points. And even if I just gave you 2 points on a line, that was enough to find the rate of change. I didn't actually teach you to find the initial value from 2 points. That's going to come this unit. But point being, from a graph, from a table, or even just from 2 points, we can get this information. This unit, we're going to talk about what to do with that. I just want to give a little piece of housekeeping, which is we often refer to the initial value as the y-intercept. The y-intercept. More often than not, initial value, starting value, when we talk about it on a graph, we talk about it as the y-intercept. Why do I call it that? Why do I call it that? Let me ask you this. Looking at this graph, what is the initial value here? Jazz? -2. Good. How'd you find that? Very good. Very good. That's the y-axis. That's the x-axis. So this is what we'd call the initial value. But we also call that the y-intercept. And the reason we call it the y-intercept is because it's where your line hits the y-axis. So it's actually a good name. It's a descriptive name. Often in math, I hate the names we give things because they're confusing. I don't think this is confusing. I think this is a good name. We're going to get to some things I hate in about 3 seconds because they're confusing.
Oh, sweet. I love confusing things.
I know you do. So that's just a little piece of housekeeping before we get to this. In the first unit, we like to very conceptually always talk about the initial value using that phrase. This unit, once in a while, I'll throw the word initial value out there, but more often than not, the term we use is y-intercept. These terms are synonymous. What's synonymous mean? All you English students.
I'm not English.
But you speak.
I speak English, but it's
There we
not
go.
like I
Okay,
know
just
everything
checking.
in English.
What are synonyms? 2 synonyms are words that
That
mean the same thing. Shh. So the adjective.
I want to land your English student.
That's why I'm a math teacher. The adjective form of synonym is synonymous. So if you're describing 2 synonyms, you can say that the 2 words are synonymous. Yes, I can. I just did.
But you can't even say adjective right.
I can't do math right, but I teach you math every day. Listen, my job isn't to be able to do these things. It's to teach you to listen. Do you think Usain Bolt's running coach can run as fast as he can?
Yes, never.
Of course not. Usain Bolt's the fastest person in the world. So why does he need a coach?
I love them.
Why? Why does he need
Someone to guide him.
someone to guide him? Someone to look. My goal, listen, and I mean this from the bottom of my heart. My goal as a math teacher, my goal as a science teacher is not to be smarter than you. Most of you are much smarter than I am. I just have the virtue of being older than you are and having gone to enough school that I know a bit more than you do. I find this all the time. I haven't taught math that long, but I taught science for about 7 years. And so I've had the chance to teach kids all the way through high school and see them go off to university. And I have some kids now in 3rd year university who send me emails and tell me what they're doing. I don't know. I don't understand what they're doing. It's way beyond my understanding. Some of the guys who went into like physiology or engineering, the science they're doing is totally different from the science I did in university, which was biochemistry. I don't understand a word of it. And it's funny because I have this crew of kids who ever since they graduated high school always send me their papers to edit. And this year, this kid Kyle sent me a paper to edit, and I had to email him back and say, I can't edit this. Like I can edit the grammar, but I can't edit the content because I don't understand it. Like it's just beyond what I know. Like I'll give it a shot, but you're officially too smart for me. And that's the goal as a teacher. My goal isn't to be Usain Bolt, as you can see. My goal is to be Usain Bolt's track coach. My job is to watch you running and say, well, eating some bacon, And you can tighten up your form there a bit, kid. And that's all I'm looking to do, except in math terms. Anyway, I like it. Anyway, so here's what I want you to do. From this graph, I want you to take a minute and tell me what the y-intercept and, a little bit more complicated, tell me what the slope of this line are, please. So take a minute and do that. Tell me what the y-intercept and the slope of the line on this graph are. I want you to tell me what. We've already looked at the y-intercept. It's what? Good. So you got that one. I want you to tell me the slope of that one. Thanks, folks. That's lovely. Now find the slope of that line, please. Find the slope of the line. Yes, sir.
Wait, what about this one?
It's the general of everything, right? Something for example, what is snow? Falling.
I don't like this point. What's a good point? Nice, good point. Yeah, I like yours. I like yours. And I'll like yours too. I'll like yours too. What's a really good point look like? Super close to that one. That's the good one. There you go. Now count that one. And you got no. Okay, first of all, that is 2. But is that the rise or the run?
My points either. I don't know.
Yeah, and then is this?
I didn't really know.
Okay. By the way, Nathan, I'm going to introduce you to a friend of mine. He's a good guy. Big fan.
English.
His name is Mr. Dixon. There you go. Say hi to Mr. Dixon. He's a good guy. Good guy. And what's
Why did you say that? That is
okay. Okay. All right. What is the y-intercept here? Was it? Yeah, you got it. The y-intercept's -2. We just look at where the line hits the y-axis. That one's nice and easy. How am I going to find the slope of this line? Jazz, rise over run. So I've got 1 point already here, the y-intercept. Where can I pick another good point? At 2, 2, very good. And so if we draw our line there, what's the rise? Rise is equal to 4. What's our run? By the way, this is not the only point you could have picked. You could have picked any 2 points. Just make sure you pick good points. But in my case, the slope then is what? Slope is equal to 4 over 2. That's okay. Yep. And by the way, is this positive or negative? Positive. How do we know? Very good, because it ascends. Because as x gets bigger, y gets bigger as well. Yes? I will catch up later, okay? Sorry, but... Okay, and let me just ask this. Can we simplify 4 over 2? Does that actually work nicely if we divide it?
Yes.
What's it equal? 2 over 1, or even easier? 2. Good. Slope is equal to 2. By the way, listen. This is another one of those things. 4 over 2, a correct answer. If you had 6 over 3, that's a correct answer. If you had 2 over 1, that's a correct answer. Those are all correct answers. This is just the simplest answer. And so it's the one we like best. We like simplicity. But any of the above would be an okay answer. Does that make sense? Now, what we can do with this is we can make an equation that models this line. Now, you've already made some linear equations, right? In plenty of our word problems, you were asked to make an equation that would model something, right? Today, we're just going to show you the form that can always follow, what you can always do this. If you know the slope and you know the y-intercept, then we can use a type of equation. And we call it the slope-intercept form. Why do you think I call it the slope-intercept form?
Shows the y-intercept, and then it shows the slope as well.
Yeah, because the two pieces of information we need, for this equation are the slope and the y-intercept. So if you know the slope and you know the y-intercept, then you can make an equation for the line. And what do I mean by an equation for the line? This is key. Look, because this is the part people always miss. I know when I was in high school, my grade 9 math teacher was a lady named Marg Epp. Amazing lady, lovely lady, super kind. But she put this equation on the board and she said y equals mx plus b, which is what I'm about to show you. And then she said, this one's the slope, this one's the y-intercept, that's what you do. And I don't think I understood why. Listen. I don't think I understood why we did this till I was about 20 years old. And all of a sudden, when you understand why, it makes doing it a lot easier because it feels like it has a context. So listen. Listen. Please listen. This is a poor time to be drawing. This really is the entire unit boiled into one sentence. All right? So pay attention. Don't draw Spider-Man. Don't draw whatever it is you're drawing. Just look at me. So the entire reason to make an equation of a line, listen, is this. We want an equation wherein I can put in any x value I want, any x value, you can imagine a graph. I could pick any number on the x that I want, and using this equation, it will tell me how high up I should go on the y to land on the line we're making. Does that make sense? You can think of a line that we draw on a graph as being made up of just billions and billions of points. Does that make sense? If you ever look at, like, has anyone ever in science class looked at a newspaper under a microscope? Anyone ever done this?
No.
I see paper under a microscope.
Okay. Have you ever looked at like printing on it? Because all they do when they make, or like if you put a photograph or anything that's been printed, if it's been printed, it's usually just dots. You know, they measure the resolution of the printer in dots per inch DPI because they just put dots. But when we step back, it looks like a continuous picture because we're seeing it from far away. Has anyone ever looked at the phone under a microscope? Oh my God, do yourself a favor. Next time you're in science class and there's a microscope around, take 30 seconds, ignore the teacher, don't tell her I said that, okay, because I'm afraid of them all. But take your phone and put it under a microscope. I'm not even going to tell you what you'll see, except to say it'll blow your mind.
Are you going to see different colors?
Just, you will not see God. Where? At the microscopes.
Yeah, no, I mean,
It's like tables of them, and they're
no,
everywhere.
but like, are you just we don't have science.
You put your
Are you looking at the screen?
look at the screen. Turn the screen on, put something on it, and look under it, like move it around and see how they make the different colors and stuff. I don't want to spoil the surprise for you. It's amazing. Anyway, listen. Listen. So all a line is a bunch of individual points. Does that make sense? Now it's actually an infinite number of points, but you can find any points on a line. And listen, because here's what I don't want. I don't want in 2 weeks' time to be saying, well, I don't understand why we're doing this. You never explained it to me. I'm telling you right now, this is my insurance policy against that statement. I'm explaining it, and I'm going to explain it very clearly. If you're not listening to me, it's on you. But listen, the whole reason we make this equation is we can find exactly where any one of those points that makes up the line goes. We pick any x value we want. We say, well, where would the line be if I go over to 2 on the x-axis? You use this equation, it will tell you where to go on the y. Then you could say, well, what about 3 on the x-axis? It will tell you what the y should be. And you can just keep doing that and find every single point on that line. That's why we make an equation. And in real life, when I used to manage a restaurant, we used systems like this because when I had to order steak for the week, I had to phone our distributor and order steak. If I order too much steak, what happens? It goes bad. It's wasted. You lose money. And believe me, running a restaurant, you do that a couple weeks in a row, you've blown your month's profit. You do it a couple months in a row, you'll go out of business. It's a very tight profit margin. The last restaurant I managed, we did $3 million in sales in a year. Our profit was about $80,000. That's a tiny, tiny little sliver. Tiny sliver. So you got to be careful. So we used to use an equation like this, where I would say, well, how many reservations do we have on them? And we had a linear equation. We knew that based on how many reservations, we know that 1 out of every 4.2 guests ordered the steak, and we could very accurately predict how many steaks we had to order. We didn't have to throw any out. And we didn't run out, because that's bad too. People don't want to come to a restaurant and say, oh, I want a steak, and have you go, that's a problem, right? Yeah, let's talk about that, right? So we use things like this. When anyone ever crossed the border to go to the United States? Does anyone ever cross the border to go to the United States when there's like massive lineups and there's only 2 lanes open, and you just feel like you're sitting there for days staring at the empty lanes thinking, why in God's name is there no one in that booth for me to go through? And then you look and you see like 8 border security agents like sipping coffee on the side, and you think, oh, I hate you all. Anyway, but you don't want to say that to them, because they can hold you like for like 7 days without even, you don't even get to call a lawyer. So don't tell them you hate them. But anyway, the point being, how do they decide how to staff those lanes? They build an equation like this. So they say, on an average Tuesday, how many cars do we expect to go through? How many border agents does that mean? So these kind of equations pop up constantly in real life. My wife loves to sew. She's a seamstress. That's one of her hobbies. She has to use an equation like this, where she has to know how much material to order if she's building a certain thing, and how to size it. She's building something for me, it requires more material than if she's building it for my son. Makes sense, right? And those sizing scales are based on equations like this. So these kinds of equations come up all the time. Why make an equation? Because we can put the X value we want to. Once I have an equation like this, I can say 500 people coming through the restaurant this week. Boom, tells me how many steaks to order. Next week, oh, it's a long weekend holiday, we're going to have 1,200 people. Boom, gives me my new number. I can order accurately. The border guards, they can say, oh, it's a football game. So we expect this many people to cross. Oh, better put this many booths open. Right? Go to the grocery store on a Tuesday and see how many checkout aisles are open. Go to that same grocery store on a Saturday and see how many checkout aisles are open. This is the thinking. Those managers who do it. Why doesn't a grocery store want every checkout aisle open every day?
They lose profits.
Yeah, because it's expensive. They have to pay people to stand at them. Yeah.
It's extra quantity of people that are coming.
That's right. So X is our dependent variable. It's the input we put in. But that's why we use these equations. This isn't some magic black box. It's a way of looking at a line where we can put in the X value, and it tells us exactly the Y value we should get to land something on that line. So let's talk about what these letters stand for, because this has a couple stupid letters. We know what Y stands for. That's just how high on the Y-axis. That's how high a point is on the Y-axis.
You write this down?
Yeah. And I want to make a note. We think of this as the output of the equation. This is what the equation is trying to tell us. Does that make sense? We're going to use this equation, and Y is what we want to know. What is the thing that we're going to put into this equation? Yeah, we're going to put X in. Every time we want to use this equation, we are going to input a value of X. If this equation was for me to know
How many chicken nuggets you need to feed family of 5?
perfect, there you go. Then X would be how many family members. And the Y, the output, is going to be how many chicken fingers, or chicken nuggets I should purchase. So this is where the point is on the X-axis. Oh, need that definite article. There we go. That's better. On the X-axis. Otherwise, you sound like my university. I had a university professor who was a brilliant lady and amazing, but she was from, I want to say, Slovenia, and she didn't believe in incidental words like and the and I and you. So she would say things like, where point is on X-axis. And then she'd say it really quickly, and I couldn't understand a word this woman said. And that's when I did miserably.
How high was it?
Okay, so the y is just going to be the output. That's how high the point is going to be on the y-axis. The x is what we are going to put in every time, and that is what the point is on the x-axis. But then there's two things, and these are both variables. They both change every time we use the equation. They're going to change depending on what x value I put in. Every x I put in is going to give me a different y value. But there's two things that define the line. And the two elements that define the line are this m and the b. Now, for whatever reason, they use the letter m to stand for slope. I don't know why they use the letter m. I spent hours one day looking on the internet for a good explanation of why they use the letter m. I found 4 or 5 explanations that all seemed incredibly dubious. I don't trust any of them.
What they say.
They like, it comes from the French word monter, which means to climb. Because slope is like climbing. I think that's nonsense, especially because the first person we have a record of using the letter M is an English guy. You would think, right? S for slope. R for rate of change. Those two letters would have made sense. They didn't. They used M. But if M is the slope, what two pieces of information did we just gather about this line? The slope and the initial value. Very good. And we're going to call that initial value, this unit, mostly what? Y-intercept. Though initial value is a completely correct answer.
Wait, why is y-intercept?
Again, could not find a good explanation. It's just the letters they use. That's right. Now I know why they didn't use I. I has a different meaning in math that you'll come across later on. Yeah, C for cross. Anyway, for whatever reason, they have chosen the letter M to define the slope and B to define the y-intercept. But what it means is this. You can make an equation for any line if you know its slope and you know its y-intercept. Now look at me. When you make the equation, the y is not going to be a number. It will just be y. The x will not be a number. It will just be x. Those are variables. But the m is going to be a number. It's going to be a constant. It's going to be a number that we put in and it stays in the equation. It doesn't change. And it'll just be whatever slope you measured on the graph. And the b will be a number. So your equation will have two letters in it. It will have a y. It will have an x. But the m and the b are replaced with numbers. So for this line right here that we found, what did we say its slope was? 2. What did we say its y-intercept was? -2. Okay. We are now going to make an equation for that line. Y equals, y equals, the slope is 2. So we're going to say 2, and then the x, 2x, and then plus -2 sounds a little clunky, so how am I going to write that? -2. If you said plus -2, you'd be completely correct. It's just, no, I would give you the marks. It's just clunky. Now, what that means is this. If I want to know how to get a point on that line, I just put in an x value, and 2 times that x value minus 2 will always be the y value on that line. I can pick any x value I want. And we're going to do that now. Let's use this equation to find a few points and make sure we're right, make sure they fall on the line. So we'll do the first one together. In the first one, we're going to see what happens when we let x be 3. So how am I going to write that? Well, first I'm going to have to start with y equals 2. And then, in place of our x, we're going to put the number 3. Because x is equal to 3. And then what do I have to do with it? 2x minus 2. Okay, y equals 2x minus 2 becomes y equals 2 times 3 minus 2. Well, what does that work out to? What's 2 times 3? 6 minus 2. And what's 6 minus 2?
4.
4. So what will the coordinates be then? What was our x value?
3.
3. And what y value did it give us?
Give us 4.
4. So if this equation is correct, the point 3, 4 should be on our line. So let's go check that. I'm going to put a red dot for it. So let's go up here and look. 1, 2, 3, comma 1, 2, 3, 4.
Wow.
Did it fall on our line?
Yes.
Yeah, good. Does that make sense? The reason it works is that this equation lets us plug any x value that we want in, and it will tell us how high or how low to go on the y-axis to see where to put the point. And it will always fall on the line. I want you to try the next two.
We don't have any homework.
We will.
What?
Oh, yeah. So don't you worry. So I want you to try the next two. Use the equation to find the point we get when x is equal to -2 and the point we get when x is equal to 0. And I'm going to walk around and say encouraging things. Like, good job. And, oh, just keep trying.
Like, how do I do this?
Okay, so what is any line can be defined by y equals mx plus b squared, and this is slope, and b is y. So in this case, y equals 2 times x. This is slope 2 is 2 minus 2 is 0. So here, you're going to use that equation. But when you get to x, what number are you going to put in? Good, so do that. Y equals, well, go through it. 2, and then instead of x, open a bracket and put the value you want for x. Good, good. Close the bracket and keep going. Okay, now do that. You can do that. You can do it on a calculator. You can do it just step by step in your head. Just put exactly how you see it here. Yeah. Times -2. Yeah, -2. Okay, so put that. Good. So now, what are the, open a bracket, let's write these coordinates down. Yeah, we're going to put a point. Right, like just like we did here. So what was your x value? Good. That comes first. And then what y value did that give us? Good. Now go put that on the graph. So -2 and the -6. Yep, you got it. 2. That's 5. Yep, good. All right. That makes sense? And does it fall on our line? Of course it does. So does it. Positive times the negative is? And then -4 minus 2 is now?
And I did.
Yeah. Because if you have -$4 in the bank, you'll spend $2 more. Now, does that make sense? Cool. Yes, sir. Yes, of course, yeah. How's that? Oh, that's great. But just put your points in brackets. You always put a point in brackets. Yeah, put them on the graph, make sure they fall on the line. Yeah, put them on the graph, make sure they fall on the line. Oh, good. I know you did. That's okay. So,
It doesn't bother me. Yeah, I know. And people always thought that was like
It's not wrong, but it is wrong. So you usually just say, when the actions, place that house.
Make sure that you crash it.
Where you have the whole class in the back of the room, it's really awkward.
Should be taken out into the hall.
You had to do it in front of our whole class. That's what I have to do too. And also, then when you have to eat, no, it's like, okay, I'll kill you. I love that.
Oh, it's great. Can you put the second line in?
I love that.
I'll come to you. You can grab a seat. There you go.
Thank you. What do I do?
It's hanging in the baby.
No, I already have.
It's a great idea.
How do you change the color back to blue? How do you change the color black to blue?
Oh, sorry. There you go.
Just throw a giant. Someone's house. Yeah, I know.
I went to eat weed and I thought because I don't believe in dancing. I know, yeah, I saw that. My wife and I were actually taking the dog for a walk and we saw on the sign like school dance. I thought, what is this place? No dances when I was here, that's for sure.
Because it wasn't obvious enough.
Well, you know.
Thank you, Lane. Good job. Are you gonna put it on it? Perfect.
Where is it?
Was that one? -2, -6. Oh, -2, -6, right? Yeah, you got it. Good job. Thanks. Do you mind doing the last one for me?
No.
Good, I'm glad you don't mind.
No, I don't want
That's what you said. I think you said inadvertently. Oh, it's stuffing the wuss. Do it.
to. I
You
don't want to do it.
did great. It's the right answer. Yeah. Oh, it's almost the right answer. I lied. What's 2 times 0?
0.
Good. 2 times 0 is
Oh,
0. And 0 minus 2 is?
2.
Is
-2.
-2. You got it. Sorry, I wasn't going to embarrass you there. I just, when I looked, I thought it was right. But you did. This is how we learn. I'm sorry. Now I feel guilty.
It's okay.
But you did great.
Oh, God.
It's like, oh, that's right when I looked at it, it's like, it doesn't look right.
This is so weird.
Okay, listen up.
It's a big Y.
Listen up. Hey, look at it. So, hold this way a second. Looking at the second one, we substitute 0 in for x. So y equals 2 times 0 minus 2. Beautiful. 2 times 0 is 0. And 0 minus 2 is? -2. So our coordinates now, the x is going to be 0. Oh, x is 0.
You have to put the X first.
Yeah, x comes first.
I don't know.
What?
The x comes first. So the 0 comes first.
Oh.
You got the right numbers. Make sure you put them in the
How do I erase?
I just use the backs, just like normal. Isn't that fun? Admit it, that's kind of fun.
-0 now.
-0 is the same answer. -0 is still just 0. Sure it is. 0. Okay, fantastic. Shh. And hey, does that point fall on our line?
Yes.
Well, let's take a look.
Yes.
If we go up here, x equals 0, y equals -2, is that on our line?
Yes.
Yeah, you bet. Okay. Shh. And Lane was kind enough to do this one for me. Shh. When we substitute x in as -2, we say y equals 2 times -2 minus 2. 2 times -2 is -4. -4 minus 2 is -6. It's very good. -2, -6, and does that fall on our line? Jazz? Thoughts? Focus in, please. -2, -6 does fall on the line. It's right there. Good. Okay. I want you to do these two, and I want them done quickly. Focus in. Next page. Get these two done. I want to know the y-intercept. I want to know the slope. I want to know the equation of the line. Get on it. They're done. Oh, you headed to your... do you guys have an in-class today? Is that tomorrow?
Gotta get my picture taken at the
Oh, have fun.
Like, I mean, I get the first thing.
How many days a week do you go to the board office? Spend more time than other than yeah. Okay, I want you to do this. What's the slope?
Online. You want something the equation I just did.
You want the equation we just did?
Okay, so how do you show that? Okay. Yes, that's the slope. What's the y-intercept? You need the slope, the y-intercept, and then the equation. Slope, y-intercept, equation of the line. You don't know how to do that? Here's your space. Hello.
Yeah.
Can I create something that she could realize? Why'd you take me into this? I don't know.
I want practice. You're not wrong, but I want to do Any answer, 2 million. You put 2 million in, if you put -64,000, X can be anything. Into the equation. So X, listen, the reason you leave it in X in the equation is because that makes it equal to all reasons. What we want the equation set up so that we can put whatever variable we want in and get the output. So again, think of it this way. Imagine you're making an equation that's going to tell you how many states are by base and how many people are
Why
going
don't I
to
take pictures like
You
this?
want an excellent because that's going to be how many, and you want a y because that's going to be how many states. So then when we're ready to use that equation, if I know I got 300 people coming through this, I can put that into my equation, and it tells me 5 to 10 states. I built a computer system up with exactly that. An inventory management.
And then I have this photo.
Yeah. This one. Calm down.
Oh my god. When I was
What's the question?
Teach me how to act about this.
I want you to find slope. I know you're not do that. Find slope of the line. Find the y-intercept.
and then I have the one about
Y-intercept.
Oh, I
On here. Where's the y-intercept?
don't. I mean, something like that. I saw her face.
Initial value. That's the y-intercept. I didn't explain to you, by the way, if you were on time. It's not my responsibility, Lane, to come every single person watching the class. Understand that? I'm not saying that to be rude. You understand? Because if everyone did that, I couldn't do it. I mean, I'm happy to help you, but like, it's not that I didn't show you. And those are subtly different things. And I'm not trying to get after you, but it's an important distinction. So when you look at the line, you want to be. 1 second. Hey! Ladies, are you done? Then you should be focused. Gentlemen, are you done? Then you should be focused. I'll be there in a moment. Ladies, I'm taking the phone in a moment. Are you done? Then get to work.
That's all it is.
Plus whatever you want. What piece of information do you need?
Wait, Shayla.
How are you doing? Okay. So what we're doing?
Wow.
Okay. So it's gonna be y.
Well, that's just rude.
What just happened?
I don't know how to feel.
Find any points on this line, even if the line extended to a
Wait,
million.
that's fine.
Not mine.
You'll find where it's
Write that down there.
Guys, listen. That's fine. It's too noisy. Sorry, when I say guys, I don't mean you guys. I mean the room collectively. It's too noisy. Doing math. I'm hearing 60 conversations. I'm seeing a million different things going on. This is complicated stuff, and you're gonna get left behind if you're doing everything but the math. I promise. And you're in a grade 9 academic math class. Right? If you want to be in a math class where you can spend 40% of the time chatting with the person next to you, or on the phone, drop to a different stream. That's not this class. It's not going to be successful. We're getting into tricky stuff, right? You need to go through and do the work. You need to focus, right? Happy to have a good time, but you need to focus. You're not going to be able to keep up with this stuff because this unit comes quickly. I'm going to go as slowly as I can. But the reality of the matter is, the material just keeps coming. You got to focus in. You're not going to get it doing everything but math, I promise. Then you're going to come and complain to me. And so, I don't get this, I can't keep up. But you spend 40% of your time doing something different. If I spent 40% of my time at work doing something other than my job, I'd get fired. Focus. Do your job. Job's to be good. Okay. So we need two pieces of information. Yes. We need y plus lx plus c. You need to put a number in front. You need to put a number in front. What is that? When I look at this line, I'm going to have to find the slope. And then b is. What is it? So if you have to realize these information,
Okay, fine.
you can make it work. Really quick, that's the initial values. How do you find this? You got it. Let's see. You did great. So that's rise and run. Now what's the actual slope? When do you know rise and run? That's just what we call
The rise is one right there, and then the tiny little.
Oh, there. Maybe that goes there. The rise is. Good. So it's gonna be -3 over what's your run? Perfect. So it's going to be -3 over. Good. So this is the. You don't want to put a value in front. You want to leave that as the letter x. That makes the equation useful. You say it's equal to -3/x. Let me tell you why. Because this is the part that always confuses me, and I totally get that. Here's why. We want this equation to still have a y and x so that we can use it to do something. So when we get later on in this unit, we'll use something like this to say, how much fuel am I going to need to drive over? I know what how if you go in, if you find simple process, long that x is going to be the number of grades, in this case, how far I'm going. And the y will be how much fuel. So we want those two.
Oh, yeah.
They let us put whatever value we want to get a number of. Does that make sense? So we don't want to put a number there until we're ready to use it.
You can't do it today.
Then we'll say, hey, I know I'm going to Toronto on this day.
Thursday soccer practice.
Then I
Right.
would take that one.
Wait, today. Six.
It doesn't mean we're unfinished.
Oh, when me and
What's more? We're on a 5 practice.
I heard my name.
And just make sure you know that actually next to this whole thing is not. So I mean, like it's 3/4 or something. Okay, just want to make sure we know that. That's good. Okay, let's go through one of these together. Look here, please. Look here, please. Okay. to come up with the equation of a line, there's only two things we need to know. It's the purple things here. Every line can be defined by its slope and its y-intercept. If you know the slope and you know the y-intercept, you know everything you need to know about a line to make it. So, to make our equation, the y stays a y. We want that to be our output, whatever. The x stays an x. We want the equation to have a y and to have an x so that we can use it to put whatever value we want in and get the output. If this were an equation to tell us how much gas we needed to get somewhere as a function of the distance we're going, we want it to have a y and an x. So I can come back later and say, oh, my trip's 200 kilometers. That's my x value. How much gas do I need? And it'll spit out the y value. So all we ever need for this equation is a y-intercept and a slope. So let's look at this first one. What's the y-intercept? Yeah, Alex. Very good. This is the y-intercept. What letter do we use for the y-intercept again, by the way? It's so stupid. Yeah, we use B. God knows why we use B, but we do. So B is equal to 3. So that's half of the information I need. What's the other piece of information I need? Yeah, the rise and the run so that I can get the... Good. So I have already a good point here. What would another good point be? Yep. Like 4, 0 here? Oh. Well, that's embarrassing. No, it's okay. It's my kid's school. They're calling because my daughter's homesick, but I know that, so it's okay.
Oh, are they just gonna get in trouble?
No, they'll call my wife next. You know, and hopefully my wife's home. It'd be awkward if it's just my daughter home. Anyway, she could answer, "No, I'm home. It's good." Okay, so in this case, what is the rise? 1, 2, 3. And what's the run? Very good. And the run is 4. So then what's the slope? Very good. And what letter do we use for slope? M. God knows why. It's 3 over 4. And is this one positive or negative? Negative. How do we know it's negative? Yeah, it descends. It's going downhill. As x gets bigger, as we go to the right, y actually gets smaller. So it's descending. So it's negative 3 over 4. So there we go. We know the y-intercept. We just look at the graph. We find the slope by looking at rise over run. Once I know that, what is the equation of this line? Y equals what? Y equals what? Yeah, you gentlemen back here. What do we got? Y equals mx plus b. So in this case, it's what? Y equals negative 3 over 4 times x plus 3. Good. Note, the equation still has a y in it, and it still has an x. That's because these are what we call variables. They change. We can put any value of x we want into the equation, and it will tell us the y. Yes? Here's the deal. Putting negative 0.75 is 100% correct. Nothing wrong with it. It's a good answer. It's a correct answer. But I don't love it because in the next little bit of this lesson, which we will get to today just barely, you're going to see that having it as a fraction is helpful. It is mathematically 100% correct to put it as a decimal. You're not wrong. You get the marks. But when you go to do the next stage, it being a fraction is a really helpful thing. So my advice is to leave it as a fraction. Okay, over here, what 2 pieces of information do I need again?
Wait, Mr. We go back to the first one.
Yep.
What did we put in for x?
We didn't put anything in for x. I just want the equation.
Oh, I thought we were supposed to.
Nope. I just want the equation. That is the equation. I could put anything in for x, and it will tell me the y. If I put 1, or if I put, what's one that works nicely? If I put negative 4 in for x, it's going to tell me that the answer is 6. All right? You don't have to do this, but let me just show you that. Y equals negative 3 over 4 times negative 4 plus 3. Well, negative 3/4 times negative 4 is positive 3, so that's 3 plus 3. 3 plus 3 is 6. And so the point I would get here would be negative 4 comma 6. Does that fall on our line? Negative 1, 2, 3, 4, up to 6. There it is.
Wait, shouldn't it be -3? It's going down.
No, this is the y-intercept. It's the y-intercept. Again, you don't have to write that. Just, I wanted to answer his question.
You probably told us a million times. How old are you?
I'm 33. And the age Jesus was when he died, if that helps.
Oh man.
How many people?
Okay. He was still doing, he started his ministry, and he was in ministry for 3 years. I don't know why I know this. That's a good memory on me. I haven't studied that in a long time. But I do know that, actually. He started his earthly ministry at 30, and he was crucified 3 years later.
Did you go to a Catholic school?
No, I went to Eden in St. Catherine's, which is a Christian school.
Wait, like
But- Yeah, that's right. Okay, so let's try this one. What 2 pieces of information do I need to make an equation of a line? Yes, ma'am. Perfect. Can you tell me the y-intercept on this one? Very good. And that's right here. So the y-intercept, and what is the letter we use for y-intercept? B. I don't know why we use B, but we use B. So in this case, B is equal to 0. And I need to know what other piece of information? Good. And in this case, I like this point, and I think I like this point. Yeah, rise is 1. Run is equal to 5. And so the slope, what letter do we use for slope again? M. Is this one positive or negative? That's ascending. As x gets bigger, y gets bigger. If we were walking along this playing Mario, we'd be going uphill. M is equal to 1 over 5. So what's the equation of this line? Yes, ma'am. Very good. That's 100% correct. I like it. I'm just going to say, do we need to say plus 0? It's not wrong. You'd get the marks for that. But just in terms of simplicity, I don't tell you that I'm 33 plus 0 years old. That'd be weird.
You figured out what are you?
Wait, you're only 33?
That's correct.
Whoa!
No, he's only 29.
Okay. Last thing we're going to talk about today. Last thing we're going to talk about today, and then I'll leave you with some homework, is I've just shown you how to get an equation from a graph. We can go the other way. If I give you the equation, we can put it on a graph. Okay, from this equation has 2 numbers in it. What are the 2 numbers? 2 over 3 and 1. What do these 2 numbers tell us? What is that -1? Is that the M or the B? The B. And what is B?
Intercept.
Yeah, that's the y-intercept. And what is the 2 over 3? What is that 2 over 3? What's that number mean? It's the M. Good. So M is 2 over 3. And what does M stand for? Slope. It's a good thing mathematicians don't teach kids how to read, or no kid would ever learn how to read. Like, imagine like a little picture book that says like M is for slope, B is for y-intercept. That kid would never learn anything. That kid would like go through his life like completely illiterate, but very good at math. So there you go. Though I don't think you can be very good at math if you're illiterate. So
On the board with the ABCs, go from there.
oh, that's a good idea, actually. That could be really cute. I like that. Okay, so now I want to talk about how we graph here. Look at me. Okay, that was good. All right. So, what is, of the y-intercept or the slope, which one of those is a place on a graph? Nathan, what do you think? The y-intercept. The slope tells you the shape of the line, but doesn't tell you where the line is. So what's the only piece of information from this we can put on the graph first?
The 1.
Yeah, the y-intercept. And in this case, it's at -1. So where on this graph does that go?
Under the 0.
Yeah, right here, right?
What? Isn't it 1?
It's -1, right? Yeah, it's -1. No problem. That's okay. So b is equal to -1. That's our y is the slope positive. Yeah, okay, I'm cool. So that's our y-intercept.
That was so easy.
Now, can I make a line from just a point?
Yes.
I mean, I could make any number of lines. Can I make a single specific line?
Yes.
What are you going to say?
I've already figured out the line.
Excellent. What do we do?
You go up to your spaces and then move over 3.
Very good. Okay, listen. Shh. That's key. The slope is equal to 2 over 3. And when we look at that, this is the rise. And this is the run. So let's start at the point we have, and let's rise and then run. And actually, I don't love the color I used, though. Let's try this.
I never use the color pink.
I find it hard to see. Okay, listen. Shh. From the point we have, we're going to use the slope to get to the next point, ladies. We're going to use the slope to get to the next point. So we're going to use the rise and the run. How much do I have to rise from my point? 2. How much do I have to run? 3. So we go up 2 and over 3. Now, how do I know if I should be going left or right when I do that?
Positive or negative?
We have to look at the slope. The slope in this case is positive, which means it should be ascending. It should be going uphill. And this gives me my second point. Yes, sir. Give me a second. Okay. So here we have these 2 points. Now, that is enough to draw a line. I have a habit that I've built, just a habit of mine. I always like to then do this again and get a third point. It's just a check. This is enough information to get a line. I like to do it one more time just to make sure I haven't screwed up. If you get a third point, it should follow the same. So again, how much do I have to rise? 2. And I'm going to actually go down from this point. No, I'm not. I'm going to go up 2 from here. And then how much do I have to run?
3.
3. And that brings me to here. That's okay. We're tough. We're brave.
I have a question. This to Orlando.
And there we go. And now listen. I want to write on here y equals, what's my equation for this line? What's the equation of this line? Y equals 2 over 3 times x. Oh, not plus 1, minus 1. Sorry about that. There we go. Okay, I'm giving you homework, and I want you to pay attention. I'm giving you homework. Okay, the first thing I want you to do for homework is put these 3 lines on that graph, and then I'm just giving you a few questions from the textbook, not a lot. I know that I just put 2 and 1 out of order. That may look stupid, but I want you to do question 2 first. I didn't like the order they put them in here, okay?
Wait, but then this value is different.
Yes, the different lines. You're going to end up with 4 different lines on the same graph. Shoot. Sorry, 1 sec. 2 to 3, then 1. 2 to 3, then 1. And then 4.
A little bit of homework, eh?
The quick questions. And that's it. 2 to 3, 1 and 4, and these equations need to go on that graph. Listen. Shh. the first half of this unit is completely essential for the second half. I know that seems obvious, but more so than maybe in other cases here, you really need to get the early stuff down pat before you can move on to the later stuff. So focus it. Good. Good.
I'll look at my textbook here, so I'm like, that one.